Well, good afternoon. I hope you enjoyed the preceding poster session. Now I would like to welcome you to session number 4. Session is focused on smart parking. We will have 5 presentations, which will be dealing with this very, at least from my opinion, very interesting topic. I would like to ask the presenters, please really strictly follow the 5-minute time frame, since there is another session just after us. But before we get to the promised topic of smart parking, I would like to give a floor to my colleague Jancho Todorov from VTT Technical Research Center of Finland, who will introduce H2020 project STORM, which is focused on smart logistics. And the reason we are including this project is that actually I am one of the team members at the Czech Technical University in Prague that is dealing with this project. So Jancho, I can see that you are ready, and the forum is yours.
Yes. Thank you, Tomas, and good afternoon, everyone, and greetings from Finland. I'd like to briefly introduce the STORM project, and as Tomas said, like Czech Technical University is one of our partners, and we'll be very happy to see you next year in the next edition of this conference, where we're planning to organize a session dedicated to this project. The project is called Smart Freight Transport and Logistic Research Methodologies, and also from the name, you could see that there might be lots of connections with the smart city concept. But just a little bit of information, the project just started in the beginning of this year, and it will continue already till 2023. And the project is focusing on identifying and screening new data sources, developing new methodologies in freight and logistics, generate use cases, including latest trends in the freight and logistics transport. As you can see, this is not a big project. We only 5 partners, and VTT Technical Research Center in Finland is leading the consortium. Then we have our partners from Fraunhofer in Germany, Chalmers University from Sweden, Czech Technical University, Department of Logistics and Management of Transport, and ERTICO is a well-known European context stakeholder organization. As well as you can see, we have a very nice board, advisory board in the project, represented by many different partners. Some of them, they're well-known stakeholder organizations like the Alliance of Logistics in Europe, ALICE, the Transport and Environment Society, and also the European Association of Automotive Suppliers. Also, you can see other companies like ZOC and Atos from the freight and logistic business. Also ABB, I think it's known by everyone. The Intelligence Society of Finland and many more. We continue the discussion with more partners to join our advisory board and provide you help throughout the project. But just in brief, what the project is all about. Here you can see on this slide listed the main objectives of the project. As you can see, the first and foremost, we're focusing on the novel trends and challenges in the freight and logistics area when it comes to digitalization, and also the digitalization of the market and the transport systems. And also we're focusing on decarbonization of the transport and automation of the transport. Basically, we're trying to identify the needs in the knowledge gaps in this area that could be made by the current models and tools that we're using as researchers. Then second objective is like to focus on data, and especially to give more emphasis on big data, how to obtain, collect, store, use, process, analyze data for the purpose of freight and logistics in order to provide more targeted outcomes on these areas from a business point of view in the future. Then we also strive to create various synthesized data based on based on broad use applications, and also to define procedures for effective management and analysis of data. Then we also focusing on elaborating new advanced analysis frameworks and models to address the new needs for structural changes in the freight and logistics transport. And then we're focusing on demonstrating everything, most of the developments in this project through use case scenarios that we're going to elaborate. I'll give a little bit more information about the case studies in my next slides. And then by the end of the project, what we strive is to provide targeted recommendation for different stakeholder groups from research and business regarding everything that we have been developing in the project related to digitalization, application of data, use case scenarios, different analysis frameworks, and none of the last time also some implications about the future policies. But then you can follow the project website, and we're going to publish all of the results there because we have promised that most of the results coming out of this project will be publicly available. Just very briefly about the project workflow itself. As you can see, we're starting kind of like a large dialogue with different stakeholder groups, large discussions with the research community, and also with academic community. And what we strive to do in this very first phase of the project that we are now to bring most of the stakeholders in the freight and logistics area, and to think through together about what are the technology drivers at the moment, and also what are the societal drivers at the moment, in order to identify the knowledge gaps that we have as researchers, and also what are the needs of the current the freight and logistics business at the moment. And we believe that through this process, it will help us to identify the gaps from the knowledge point of view, but then to identify the gaps that we have as researchers in various tools that we are developing and we have in our hands. Then we're putting lots of emphasis on the identification of new data sources on different levels in freight and logistics, and that's we have a dedicated work package. What we strive to do is to identify novel sources of data beyond what we know at the moment, in order to identify new potentials for new business model or for new optimizations in the freight and logistics. Then later on, we are focusing on elaborating novel concepts and assessment methods for those concepts, including methods from strategic assessment, setting evaluation criteria, and also operational level evaluation and analysis. And then by kind of like the second half of the project, wrapping up the information generated out of the project, we strive to organize few case scenarios, mostly focusing on the freight, logistics, and policies. And then by the end of the project, we would strive to provide targeted recommendations for different groups, different user groups in the freight and logistics area, mostly focusing on the new business models, the new service models that will emerge in the future, especially when it comes of application of data, and also about emission decrease. And then we will disseminate all the results, as I said, through the project website and the social media channels. So I would like to take the opportunity to invite all of you to follow the project and follow our developments. A little bit about the use case scenarios. As you can see, we have set in the project to investigate 3 different scenarios. The first scenario is about the zero emission freight, where we strive to analyze truck movement data of zero emission trucks and think a bit what will be the implications of deploying optimal charging road infrastructure. Then the green city logistics, we handle it together with VTT and Czech Technical University, and we're striving to kind of like study and present a case where we optimize the transport flows in the case of inner city logistics by creating a virtuous city model, and we'd be very happy to kind of cooperate with CTU and take the opportunity to use the Smart City Lab in CTU. And then the last case is about policy analysis, because currently the policies in the freight and logistics area, they need to be amended in order to match the future needs and challenges in terms of adopting of zero emission vehicles and also adopting various digital technologies. And then the impact of the project comes from different directions, mostly from generating knowledge by identifying the freight and logistics knowledge gaps and needs, by our works with the stakeholder organizations, where we strive to organize interviews and surveys to get feedback regarding valuable questions. Then we strive to develop in the project a set different novel freight and logistic concepts, and then to help the deployment of innovative and sustainable transport system using latest technologies on the market. Also, we strive to enable also capabilities for research and business together. Then other focus and impact of Storm is like the design and analysis of new concepts and methods to support the transport and mobility researchers, and then to kind of like translate all the generated knowledge throughout the project into future policies recommendations, because this is very important for this sector, and also to kind of like define future directions for research in the freight and logistics area. And as I said, I would like to invite all of you to visit our Storm Toolbox that will be available in the beginning of the next year. That will be a medium where we're going to publish all of the results. So most of our project reports, deliverables, developments, data sources, methods, softwares, and whatever we are able to open, it will be available for free. And whoever is interested in the developments in the freight and logistics area could freely connect over the website and check what we have developed so far. And if you're kind of like interested about the topic of freight and logistics, I would like to invite all of you to kind of like follow the project website and your social media channels, and in order to keep updated. And of course, we're interested to collaborate with various partners. So if you're interested to collaborate with us, don't hesitate to contact me. Thank you.
Yeah, Ancho, thank you for your presentation, of our project Storm, and I'm looking forward that next year we will be able to show our first results at this conference.
Yes, thank you, Tomasz.
And now, we will switch our attention to the United States, to my favorite city of El Paso, Texas. And our next speaker is a colleague from our long-term partner, University of Texas at El Paso, Jeff Widener, who will be talking about a smart parking garage. Jeff, very early morning, very good morning to El Paso. I hope that, well, you seem to be fresh and ready, so the forum is yours.
Thank you. So, as Tomas said, my name is Jeff Widener. I'm an assistant professor at the University of Texas at El Paso, and I'm here on behalf of my colleagues, Fernie Briones and Kelvin Chu, as well as from UTEP, as well as Okan Gerbuz from Texas A&M Transportation Institute. And we'll be talking about our project, Smart Parking Garage, Concept of Operations and User Benefits. I just want to quickly note this project was partially funded by U.S. Department of Transportation through their University Transportation Center program under the C2 Smart Center. So we had two main research questions we were attempting to address with this project. Both were surrounding the formalization of the smart garage concept in the United States in particular. So first we wanted to just define what a smart garage was, and then we wanted to quantify the potential benefits of a smart garage to the user. And so we did this through the development of a level of service criteria that's analogous to what we use here in the US to determine the functionality of our roadways. So I want to point out, and I'll mention this again, but I want to point out that in this project, we really we focused on the user, and we didn't explore benefits to the operator of the garage or system costs, things like that. So in the US, we have a lot of parking and a lot of parking garages, and most of them are what we would consider to be primitive or dumb. There are some garages, particularly in big cities like San Francisco, Seattle, New York, and Washington, D.C., that have substantial smart parking technologies, but for the most part, it's ad hoc, small distributions of smart technology in garages. And there's no formalization of the smart garage concept. So as we took on that challenge, we basically applied smart cities principles to garages, including sensing, communication, two-way communication between users, operators, and the system, and all the IT infrastructure that would support that. And the benefits are numerous. So smart garages enable real-time monitoring of occupancy for both operators and users. They simplify reservations and payment, and potentially allow the operator to shift to a dynamic parking fee structure based on demand. So the physical components of our smart parking garage per our ConOps are shown here, so inclusive of a server, sensors, mobile applications, dynamic messaging signs, and then how the user and operator would both interact with that system. And as part of the project, we did align this with the US National ITS architecture that's shown there in the middle figure, including all 4 subsystems. And then on the right-hand side, we have a typical use case of the smart parking garage. In the interest of time, I'm going to direct you to the paper for more details on these diagrams. I could just sit here and talk through them for the entire of my allotted time, so I'm just going to point you to the paper for those. So in terms of our level of service criteria, this is what we adopted to quantify benefit to the user. And so we used parking search time as our variable within this level of service criteria. And parking search time we defined as the time from entering the facility to when the vehicle has occupied a parking space. And we associated search time with different levels of service, with level of service A being good and level of service F being unacceptable. We had a survey done from an earlier project, which respondents were asked about their opinion about how long they're willing to look for parking. And we based our search time criteria on that. These values would differ for different facilities. And so on campus, we conducted a case study on the Schuster Garage. This is a roughly 700 space parking garage on campus. And what we did was we asked a student to drive to 22 different marked spots. The first run of testing, the driver didn't know where the spots were. We marked them with chalk. The garage was empty because of COVID, so we had to make do with kind of replicating the parking search process. The second round of testing, we told the driver, go to the 3rd floor, go to the north side, and then we were standing there pointing to the spot, and that was sort of simulating the smart garage ITS without having to actually, implement smart garage technology. And not surprisingly, we found a drop in the median search time of about 35 seconds. We saw broad improvement from level of service B to level of service A across all the runs. So the first run, we had about 10 spaces that were level of service B. The second run, they were all level of service A. And we assigned some value to that reduction in search time and came out with about $500,000 a year, $500,000 of benefit to the users. So again, this doesn't include any benefits to the owner or any changes from emissions or anything like that. But overall, we have demonstrated benefit of the smart parking garage in the United States. So that's it for me. Thank you for your time and your attention.
Jeff, thank you very much for your presentation. For the next presentation, we'll be still staying in El Paso, Texas, and I would like to invite the next speaker, also from the University of Texas El Paso, Okan Gürbüz, who will be discussing zoning, pricing of parking at the university campus. Okan, the forum is yours.
Thank you, Dr. Horak, and good afternoon and good morning. I am Okan Gürbüz. Today I'm going to present our study titled as Zoning and Zone Permit Pricing for Smart Parking Management at a University Campus. And as you all know that every trip begins and ends with parking, and parking is an important component of roadway infrastructure. Universities, they attract different type of users, and generally they have many parking lots across the campus. To manage parking, universities define zones, which is a grouping of adjacent parking lots into a zone and issuing a parking permits for each zone. Permit holders are only allowed to park at the assigned zones. The most common practice is the closer the parking lot, the higher the parking permit fee. In this study, we developed a methodology which is called Z2P2 that uses student value of time and last mile travel time to define the zones and recommend prices for each zone. The research question we tried to answer was, how should the parking lots on campus be grouped into different parking zones, and what should be the prices. The methodology we developed takes into account every parameter that influences the cost and the benefit of parking. That includes walking time, cycling time, value of time, the availability of shuttle service, the type of parking structure, and the parking office policies. We picked the case study from the University of Texas at El Paso, and this slide shows the campus map. Different colors with polygons represent the available student parking lots with different walking times to the geographical centroid of the campus core. And the campus core is shown by the white boundaries with a yellow pinned centroid. So what we did, we measured the walking and the cycling time of each parking lot and find the weighted averages and last mile travel times using the student survey results. Then we followed the United States Department of Transportation approach that uses the household income to estimate the value of time for the drivers. We found that UTEP students' value of time as 14 cents per minute. In other words, every minute a student saves or loses for every trip, he or she saves or loses 14 cents. Then we converted this value to a yearly basis, considering average number of visits to campus throughout the year. The median base price was assigned to the median last mile travel time, which in our case was found as 8.5 minutes. The yearly values added or removed from the median base price. And this table shows the calculated values using this approach. The third column shows the actual prices, and the last column shows the values that consider the parking garage coefficients. This is one other way of demonstration of the results. The dark blue bars represent the actual reported prices of the different parking lots, and the orange ones are the methodology results. As you can see, some parking lots located on the left of the graph are underpriced, and some on the right are overpriced. As a follow-up for our study, we use the Z2P2 methodology to develop a tool called Smart Parking Management, or in short, SparkMan. This tool was developed to help university parking offices to have an idea for the expected demand, base permit price, and the distribution of the prices for each parking lot across the campus. This is all from my side, and thanks for your interest and listening.
Okan, thank you very much for your presentation. I think that it's quite valuable now when I'm recalling my teaching at UTEP and fighting for the parking permit and so on. So I hope that the parking office will take your recommendations and will use the app. So once again, very good morning to El Paso, Texas. And now to the next presenter, we will move back to Europe, to Hungary, Budapest. And I would like to invite Dalen Silva from the University of Budapest. And we will be discussing the effect of micromobility on parking demand. Dalen, the forum is yours.
Hello, good afternoon, and thank you for the opportunity. I'm Dalen. I'm from the Budapest University of Technology and Economics, and I'll be presenting about our paper entitled The Effect of Modal Shift to Micromobility Upon the Parking Demand. Micromobility use addresses mobility gaps within the transport network and could be a result of modal shift from private car, public transport, and even walking. In this way, it could generate an increase in parking demand and in a need for urban space. Therefore, some questions need to be answered. For example, how does the modal shift to micromobility occur? What are the aspects considered when shifting? How can the modal shift be estimated? And what is the parking demand for micromobility? Our model try to estimate this parking demand and the likelihood of the modal shift considering some aspects. general aspects that could be user preference, such as transport mode, sharing, and docking type, trip characteristics, which were trip purpose, travel chain, and distance, and some endogenous factors were considered: cost, convenience, and availability. Added to it, we consider the user's actual behavior, consider the mode choice, and how these aspects could influence and could generate a modal shift. In our demand calculation, we elaborated some steps. In the first one, we calculated the current demand for parking space, which considered the parking spaces for car, bicycle, scooter, walking, and public transport in the peak time. Later, in the step 2, we elaborated a cost comparison between the transport modes and the alternatives, and a convenience comparison according to the user's preferences. So some best alternatives for transport mode and modal shift were resulted, considering transport mode, sharing, user preferences, availability of the transport mode, and the docking type. These are the formulas, the equations that we elaborate in each step. For example, in the step 1, we calculated the current demand for parking space, considering the current situation, the transport mode used by the users in the peak time. In the second step, the modal shift was determined by endogenous factors, considering the cost and convenience comparison and elaborating the best alternatives. In the third step, we calculate the likelihood of modal shift according to the planner's conservatism. We establish a percentage of the modal likelihood, of the modal shift likelihood, considering the trip characteristics of distance, travel chain, and the trip purpose. And finally, in the last step, we estimate the future demand for parking that use the same approach as step 1, but considering the modal shift. In our results, we elaborated 4 scenarios in order to estimate the parking demand and analyze the reasons behind the shift and the situation. We calculate the parking demand for these scenarios. And in the first scenario 0, it simulates the current situation. The scenario 1, it's a car dominant scenario. Scenario 2, public transport and walking. They are dominant. And in the third one, simulates basically the future when we use micromobility in a high proportion. It was discussed the shift from car, walk, and public transport, and how this shift to micromobility could increase or decrease the needs in parking demand and urban space. It was analyzed that the use of dockless micromobility, as they use existent infrastructures such as bike racks, they need less space than the docked mode. And the reasons behind when there is no shift or shift to car use, they were investigated, proving that this novel method is very useful for urban planners, governments, and service providers. In this way, I would like to conclude highlighting that our novel method tried to estimate the parking spaces generated by the modal shift to bicycle and scooter usage, considering user preferences, trip characteristics, and endogenous factors. Thank you very much for your attention.
Dalen, thank you very much for your presentation. And well, our next speaker is from the Czech Technical University in Prague, Kristina Navrátilová, and she will be discussing application of Mobility Hub for automatic parking in the city. Kristina, forum is yours.
Thank you very much. I hope everybody can hear me and you see the presentation now. I will start my presentation with a question. How many of you ever had a problem with finding a free parking spot? I guess almost everyone. In this presentation, you will see the possibilities of automatic on-street parking and how much are people willing to pay for it. Good afternoon, everybody. My name is Kristina Navratilova. I am PhD student at Faculty of Transportation Sciences, CTU in Prague. The topic of my presentation is application of Mobility Hub for automatic parking in the city. Automatic parking services can save time, reduce emissions, increase safety, increase the mental well-being of the drivers, and also help to optimize the use of parking spaces. We will focus on automated parking in urban areas. I will present you a proposal for the application of smart solutions in the form of mobility hub for parking. And this research was supported by the European Institute of Innovation and Technology under the research project Urban Smart Park. We are going to look at the 5 main points, so let's get started. Imagine that the drivers can reserve a parking space. They will use the mobile application or the in-vehicle navigation for it. This request is sent to the Mobility Hub, which combines all information about city's parking. The drivers have an online overview of the state of the traffic. The city has an overview of the free parking spaces using IoT-based sensors, camera systems, and other detectors. This includes the possibility of booking parking spaces. This figure shows the basic scheme and process of virtualization of the parking system in the city. Search and reservation of a place for charging, parking, data processing from parking sensors, and evaluation of the traffic engineering parameters with connection to the traffic control center, a possibility of parking an autonomous vehicle, and driver or passenger communicate via mobile application with central system and mobility hub. Black link represents evaluation and provision of data from city system. Blue link is data about position, and red link is data about free parking spaces. Why the survey? To assess the interest of potential users and the business potential of selected parking-related services. The idea of the self-check-in is that vehicles are automatically detected when parking in paid area. The AVP services means that the driver exits the vehicle and the vehicle then automatically drives to the nearest parking spot. Respondents were people in the countries of origin of the project partners. And what about the method? How a scenario-based quantitative online study was conducted. Results of the survey. The figure here shows the willingness to buy the AVP system as an optional feature when you're buying a new car. The majority of respondents would be willing to pay less 10,000 Czech crowns. And this figure shows the willingness to pay extra for the initial installation of this feature in the current car. In general, the differences are not so significant. The willingness to pay of respondents from the three countries are on a comparable level. So about utilization of this, utilization could be for automatization of some processes. Clear future trend is a mobility hub which can use the V2X communication. Potential customer generally see and appreciate the added value of presented parking services. The services must not be more complex and laborious to use than the current solution, and the trust in the technology must be first created. I hope you enjoyed this brief presentation, and thank you very much for your attention.
Christina, thank you very much for your presentation. And well, you you used you used exactly 5 minutes. So thank you also for keeping the time. And for our next presentation, actually, we will sort of stay with the topic and we'll be discussing autonomous parking system interface. Our next speaker is also from the Czech Technical University in Prague. So I would like to invite Alina Maško. Hi, Alina.
Hello.
The forum is yours.
Thank you. I'm glad to present you this project that we run in collaboration with Škoda Auto and UTIA in the frame of EIT Urban Mobility Project. It was a clinical study that was focused on exploring the possibility of measurement methods, assessment methods for systems like this when autonomous driving would be in a broad range introduced in the cities. And the motivation of the whole project was to introduce an automated parking system, and within our research we were focusing on study of a developed autonomous parking function and application that was developed for it. The project was run in a closed area, in a closed parking area on a prototype vehicle, Škoda Rapid, that was equipped with automated parking function. And the interface that was the object of assessment included the interface in the vehicle, the interface on the vehicle car body, that is external interface, and a mobile application interface that was in hands of subject. Our contribution was assessment of eye behavior of subjects, and we used an eye tracker Tobii Pro glasses for that. It was a clinical study. It was an experiment that where all subjects ran through predefined stages. All subjects were introduced to the vehicle interface, to the HMI inside the vehicle. Then they were instructed to send the vehicle to a parking spot using the mobile app. And then with this mobile app, they were to call the vehicle back from the parking spot and confirm the vehicle approaching or returning back to them. The results include heat maps and analysis of visual behavior of subjects based on the eye tracker data. The measurements were run during the observations of subjects of the in-vehicle interface in the cockpit. Then during all the other functions they used to send the vehicle and call the vehicle back while they were observing the design of the mobile application and the exterior of the car. As for the interior, most of the visual attention was focused in the gorgeous area, which we considered to be natural or something habitual to all the subjects. As for when being outside the vehicle and performing the sending and calling back the vehicle, most of the attention was focused on the mobile application. And the vehicle was equipped with external interface represented by a blinker on the roof of the vehicle, which didn't draw much of attention, while most of the attention on the car body was focused in the area of the bumper, license plate, and on the doors. These are the results when subjects were waiting for the vehicle returning to the place from which subjects called the vehicle back, which was called the pickup zone. And as for the results, most of the visual attention was focused on the mobile application, which we considered to be natural, as this was the interface most close to the subjects, and something that the mobile phone is just something that people are used to using. And while the external interface of the vehicle was something that was newly introduced during this experiment, and most of the attention that was focused on the vehicle was just verification of the vehicle status, what vehicle was in fact doing, where it was driving, turning, and so on, and verification of all these automated vehicle actions in the mobile application. To conclude, most of our conclusions lay in the area of recommendations of modification or further elaboration of the design of the automated parking system interface, which was split into two modules: the mobile application interface and the external vehicle interface. And from the focus of subjects in the test, from the focus of the user of this interface or the driver of this vehicle, we would recommend to place more of vehicle status information into the mobile application, so that they were provided with actual status of the vehicle. As for the external interface of the car, it would be recommended to further elaborate on its interface for its more efficient communication of other traffic participants, which would be also extension or further development of this study. That's it from us, and if you have any questions, you can contact us via email or also read more details in our paper.
Alina, thank you for your presentation. Your presentation concludes this session on smart parking. And actually the topic of your presentation, well, actually it's focused on autonomous, will serve as a sort of a bridge to the next session that will be entirely dealing with autonomous and, of course, electric vehicles. I'm sorry there was not so much, or well, actually there was no time for questions. But in this online format, we prefer to keep the sessions brief to have your attention. And so, thank you for your attention. Thank you for attending session 4. And I guess I will just invite the moderator of the next session, Peter Boknar.